Hi guys, this is just a quick video about the third question from assignment 5. Um, so we have two subsets of the real numbers. A is non-empty, B has an upper bound, and A is contained in B. Then we have to show, first we have to show that the sup of A is less than or equal to the sup of B. And then we have an additional condition for this next part. Suppose that every element of B, for every element of B, there's another element of A which is greater than or equal to B. Okay, and then we have to show that the sup of A equals the sup of B. Okay, so let's start with this first part. Okay, let's remind ourselves, what is the sup? Well, we start with A, for the sup of A. We have A, and then we have the set of all upper bounds of A. And then the sup of A, that's the least element of this set. In other words, the least upper bound. Okay, so that is what we're going to do. Okay, so so what we can show is that the set of, so since A is contained in B, the set of all upper bounds of B, any upper bound of B is also an upper bound of A. Okay. So let's take an element X, which is greater than or equal to B for all B and B. And X is greater than or equal to A for all A and A. Since A is contained in B. Okay. So basically, so now what do we do? Now B has an upper bound. So this set of upper bounds is non-empty, and so it turns out that set we've shown like the real numbers have the least upper bound properties. So this set of upper bounds has the least element. Okay, so so A is non-empty. That implies that B is non-empty. And B has an upper bound. Well, any upper bound of B is an upper bound of A. So A has an upper bound. So both of these sets have an upper bound and are non-empty, so they have a least upper bound. So you can say that like sup of A, sup of B exist. Okay. Furthermore, any upper bound of B is an upper bound of A, so the least upper bound of B has to be at least that of the least upper bound of A. Okay, so what we can say is that any X such that X is greater than or equal to B for all B contains all the upper bounds of A. Wait, did I write that the wrong way? Let's think about it. So if X is an upper bound of B, it's an upper bound of everything in A. So yeah, anything in here is also in here. Oh, wait, I did say it the wrong way. Sorry. Okay, let's think about it some more. Here we have all the upper bounds of B. Anything that's an upper bound of B is an upper bound of A. Okay. Now, what happens? The least element of this set, that's the sup of A. There's more things here, possibly, than there are here. So this least element might be less. And that is the thing we want. That's the thing we want to prove. Okay, so when you take the sup, it's the least element of all the upper bounds for the set. Okay, and if you have fewer elements, the least element might be bigger. Okay, so we have this inequality, and now it's we've shown this. Okay, now we have to suppose that for each b, we have a corresponding element of a for which b is less than or equal to a. And now we have to show that the sup of a equals the sup of b. Okay, so how should we do that? Okay, so now, we've already shown that sup of b is greater than or equal to sup of a, so now we have to show the reverse inequality. So I guess let's do a new page. Okay, so now we have to show, we must show that the sup of b is less than or equal to the sup of a. Okay, well, one way to do that is to show that any upper bound for a has to be an upper bound for b, because we showed that any upper bound of b is an upper bound for a. That shows that the sup of b is greater than or equal to the sup of a, so we're going to do the reverse thing. So suppose x is greater than or equal to a for all a. Okay. Now our goal is to show that it's greater than or equal to b for all b. Okay. So let b and b. Then our assumption is that, so what is our assumption? Our hypothesis is that for all b, there exists a and b is less than or equal to a. Okay, now we apply our hypothesis. Then there exists a with b less than or equal to a, but also a is less than or equal to x for all a, so in particular for this a. So x, so any upper bound of a is an upper bound for b. And that is enough to say that the sup of b is less than or equal to the sup of a. And now we've already shown on the previous page that that's less than or equal to the sup of b, and that implies that sup of b equals sup of a, because as we know, the real less than or equal to on the real numbers is what is anti-symmetric. Yes. Okay, so that's the end of that question. Okay, thank you for watching.